How is temperature an extensive property? The extensive property deals with the change in the temperature with the change in the amount of substance. Let us consider an example of a glass of water to illustrate is temperature an extensive property or not. Take a full glass of water, check the temperature, let us say it has acquired room temperature. Divide the water equally by pouring half the water into another glass and checking the temperature. Suppose the temperature of both halves-filled glass of water is the same as that of a full glass of water before pouring. In that case, the property is intensive. If the temperature of half-filled glasses of water is reduced to half of the whole glass of water, then the property is extensive. If you have done it practically, the temperature of the water before and after dividing is the same. Thus temperature is not extensive property. Is change in temperature an extensive property? The change in temperature is referred to change the application of heat energy. By increasing the amount of heat supplied to the substance, it will gain temperature, and by decreasing the amount of heat, the substance loses the temperature. Since the change in temperature is always associated with the heat supply, so let us take the heat energy to answer the above question: is temperature an extensive property even if the temperature changes? Heat supply corresponds to the internal energy of the substance possessing kinetic energy. However, the variation in the heat supply correlated to the change in the kinetic energy of the substance. Since kinetic energy is proportional to the mass and the velocity, the heat indirectly depends on the mass, thus, heat energy is an extensive property of the substance. We know that temperature change is due to a change in the heat energy, but the difference in temperature does not depend on the mass of the substance. For better understanding, let us take an example of water which is well explained below. If a liter of water is kept to boil, the water begins to evaporate. Even if you boil half a liter of water to boil, it will get evaporated. The evaporation of the water takes place due to changes in the temperature. But the change in temperature does not cause due to external factors such as shape and structure. But it is only due to the internal motion of the water molecule by the application of heat. Thus, the temperature is not influenced by the external aspects, so change in temperature is not an extensive property. Many people get confused heat by temperature. Temperature is always due to the internal motion of the substance, which is not affected by the external appearance and quantity of the substance. Facts to remember. Heat is not a property, it is the energy required for the substance to attain temperature. So temperature and heat are interlinked with one another. Heat always depends on the external appearance of the substance, such as shape, size, mass, and texture. Heat is a variable path entity. At absolute zero temperature, no heat is transferred from the substance. Even if the amount of heat transferred to the system to attain the temperature is kept constant, the temperature varies. So that even though heat is extensive, the temperature is intensive property. Frequently asked questions. Give some examples of the extensive property of the substances. The substances whose physical behavior is dependent on external appearance and properties are mass, volume, entropy, enthalpy, internal energy, heat, capacity, size, and amount of the substance. Why can the temperature not be an extensive property? The extensive property only depends on the amount of substance and the mass, while the temperature is independent of both quantities. When a substance possesses a certain temperature, it does not depend on the mass and amount of the substance. The temperature of the substances remains the same even if you remove some amount from them. So that temperature is not an extensive property of a substance. Heat is an extensive nature of the material. Explain why. Heat is the energy that can be transferred from one material to another material. To transfer the heat, the material's mass, density, and size are highly influential. The heat is a transfer from one material to another material that takes place in such a way that the material with different densities and mass undergoes heat transfer. One gains the heat, and consequently, another material loses its heat. Thus the transfer of heat energy is caused by the bulk property of the material. Heat is extensive. How can you distinguish between extensive and intensive property? Both intensive and extensive properties of the materials are based on the nature of dependency on the other physical entities such as mass, amount, size, and shape of the material. Any material property depending on the external feature rather than internal behavior property is known as extensive. While any material property influenced only by the internal nature and external factors of the material does not matter, such properties are known as intensive property. How do you say the temperature is not depending on the external features while the heat is? The transfer of heat from one material to another material is different. For example, let us consider heating water and iron. If you supply the same amount of heat to both water and iron, the receiving ability of the iron and water is different. Iron gets heated more quickly than water due to its size and state. So it is evident that the amount of heat transferred to the iron and water depends on the size and the state of the substance, which is the external factor. But in the case of temperature, the same amount of heat supply causes the iron and water to achieve different temperatures due to their intermolecular structure and bond, which is the internal property of the substance. What do you mean by absolute zero temperature? Absolute zero temperature is the lowest possible temperature of a thermodynamic system. At absolute zero temperature, every system possesses the lowest energy, and the motion of the atom relative to all other atoms is completely stopped. Thus, the corresponding temperature in the scale is measured to be zero. Any object cannot achieve the temperature below the absolute zero temperature because every atom has retarded its motion, and no thermal motion is left to stop below this temperature. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.